So one of the things you sort of get used to with vector equation lines is they can be written in different ways. This equation has just put them together and added vectors. Can you see that that's the same as starting with 3, 5, adding t times 2, negative 5? Because your mathematics with vectors, this t in front could go in and be 2t and negative 5t. And then adding vectors of the same size would just be adding the corresponding components. So there now we've rearranged this so our vector has a point. 3, 5 is a point. And the direction is 2, negative 5. So this is our line L, and we want to find the unit vector in the same direction as this. So a key thing you're going to have to pull out of a vector equation of a line is to know which is the point that's on the line and which is its direction. So our direction vector is always the one with the parameter. So we know that our direction vector is 2, negative 5. How do we find our unit vector? So we're going to find the length of this, and the length of this vector will be 2 squared, which is 4, plus 25, square root of 29. So our unit vector if we divide out that length, then you'll have a length of 1. And you could write it that way, or you could multiply that 1 over root 29 in. If you want to get fancy, you could rationalize the denominator. And now we're going to find the Cartesian form of our line. So in order to find the Cartesian form, we'll often have to start by finding the parametric form. Going back to here, we'd have 3 plus 2t and 5 minus 5t. Solving for t in the first one, you'd get x minus 3 all divided by 2. Solving for t in the next one, you'd get y minus 5 divided by negative 5. And then you'd have the Cartesian form. And if you really, really, really liked y equals mx plus b, that was your favorite, all you'd have to do is take your Cartesian form and rearrange it. I would probably start by cross multiplying here. Negative 5x plus 15 equals 2y minus 10. So 2y minus 10 equals negative 5x plus 15. Solve for y. So we know that our slope of our line is negative 5 over 2, which we could see already in our direction vector. And our y-intercept is 25 over 2, or 12.5. But the nice thing about a vector equation of a line is you're not restricted to a certain point that you have to start with. You're not restricted to a y-intercept. Basically, what it's telling you, if you were going to graph this, is I have the point 3, 5, because that's my starting vector. And then my direction vector says go 2 more to the right and 5 down. and there's my equation of my line. There's my graph. You've got a point to start with, and then you have sort of a slope to go with that, but just a direction vector, and you can find another point and draw that line quite easily.